This is Miss Goodwin, and today we are going to be covering Objective 3.1, Rigid Transformation. The objective is that you can use rigid transformations on the Cartesian plane with geometric figures. So first let's talk about some vocabulary. So what are rigid transformations? Rigid transformations are transformations that don't change size or the shape of a figure. The pre-image and image are congruent. We have three different types of transformations, and those are translation or sliding, reflection or flipping, and rotation or turning. Now we have two terms to describe the figures. The first one is a pre-image, which is the original figure. After you perform the transformation, that is called the image. And just some notation, the points in the pre-image are denoted with letters, so just A, B, or C, whereas the points in the image add an apostrophe for each transformation. So like A with one apostrophe, B with one apostrophe, C with one apostrophe. So those are all the vocab and notations. Let's look at these three transformations now. The first one is translation, or known as sliding. A translation moves all points of a figure the same distance in the same direction. The rule for translating some point xy is going to be adding some number or subtracting some number from x. That is going to be left or right movement, comma, y plus or minus some number b, and that is going to be up or down. So here we have an example. We are given some rectangle PQRS, which has these four vertices. -3, 5 is point P, -4, 2 is point Q, R is 3, 0, and S is 4, 3. We want to graph PQRS and its image for the translation XY becomes x plus 8, y minus 5. So this x plus 8 means we're moving to the right 8 and we're going down 5. So every point is going to move right 8, down 5. So it's already done for us, but let's check. So P was -3, 5. We added 8 to our x and subtracted 5 from our y. So we go 1, 2, 3, 4, 5, 6, 7, 8. That's plus 8. And then 1, 2, 3, 4, 5. That is minus 5. Y minus 5. And we ended up at P prime is what we can call that. And if we were to do that to every one of them, we would see that every point is to move to the right 8 and brought down 5 units. So this would be our pre-image. And this is our image. Let's look at the next example. So we are given triangle PQR with vertices P, which is -3, -2, Q, which is -1, 4, and R, which is 2, -2. And we want to perform the translation x plus 2, y minus 4. Okay, so I've gone ahead and drawn our triangle. Now let's do our transformation. So to each of our x's, we're going to add 2. And for our y's, we're going to subtract 4. So our image of P is going to be at -1, -6. Our image of Q is going to be at 1, 0. And our image of R is going to be at 4, -6. So let's go ahead and graph these like so, and you are done. So all we have to do is just slide our triangle over. So that is translation. Let's go ahead and move on to reflection, which is also called flipping. So reflection is flipping a figure across a line or a point of reflection. And we have 4 different rules here that we're going to look at. So let's say we flip across the x-axis. If you start with some coordinate AB, your new coordinate will be A, -B. Notice the y coordinate is what changes. So remember, the x-axis is this one right here. We're going to flip across it. Now, if we flip across the y-axis, your new coordinate will be -AB. So notice the x coordinate is what changes. Now, let's say we're reflecting across the origin. So that is the center point on the graph here. We will actually be switching the signs on both coordinates A and B. Whoopsies. Okay. And then let's say we're flipping across the line y equals x. You're not going to change the signs, but you are going to switch the order of the coordinates. So instead of AB, it'll be BA. And that is going to be this line right here that we're flipping across. Okay. So let's look at this example here. Quadrilateral KLM has the vertices K 2, -4, L -1, 3, M -4, 2, and N -3, -4. Like so. And we want to graph the quadrilateral like I did here in its image, which is a reflection across the x-axis. So it's going to look like this guy right here. So as we can see, the math's already done for us. All the x coordinates stay the same, but we do flip the sign of the y coordinate. So let's start with K. So K is 2, -4. We want to graph the image, which is at 2, 4. So 2, 4, right here, and that is the image of K. Now let's do L. So L is at -1, 3, and its image is at -1, -3. So that's going to be down here. M is -4, 2, and the image of M is -4, -2, right here. And last but not least, N is -3, -4, and the image of N is -3, 4, right up here. Okay. Go ahead, connect our points. And we have reflected the image. Now, it is okay if they overlap a little. That is completely normal. Okay, it doesn't affect your answer. So the x coordinates stay the same, but the y coordinates change signs. So if it's positive, it's negative. If it's negative, it's positive. Let's do another example. So for this example, we have a square QRST with the vertices -1, 4 for Q. R is 2, 5, S is 3, 2, and T is 0, 1. So I've gone ahead and graphed our pre-image. Now we want to reflect it across the x-axis. So we're going to cross this axis right here, and to find our new coordinate, we just change the sign on the y coordinate. So -1 is our x. In Q, we'll keep that the same. but the positive 4 is going to become a negative 4. And that is going to be at negative 1, negative 4 right here. That is our image of Q. R is at 2, 5. So the image of R is going to be at 2, negative 5. Keep the 2, change the 5. So over 2, down 5 for the image of R. S is at 3, 2. So the image of S is going to be at 3, negative 2. And then T is at 0, 1. So that's going to be at 0, negative 1. Which is right here. And we are done. Now let's move on to rotation. So rotation is the same as turning the image. A rotation will turn every point of the pre-image through a specified angle and direction about a fixed point called center of rotation. So you're just going to turn your image about a circle. You could rotate at any angle, but we're mostly going to focus on just the 90 degree, 180 degree, and 270 degree rotations. And we're going to cover those rules right now. So there are two different directions we can go in. The first is clockwise, and the second is counterclockwise. If you've ever looked at an analog clock, you'll notice the hands move like this. That is clockwise. And if you go the other direction, that is what we call counterclockwise. And you might see me abbreviate them as CW or CCW. Okay, so just keep those in mind as we work through these different rules. So, type of rotation, we're going to rotate clockwise 90 degrees. So, just like that. If we start with some coordinate XY, you're going to switch the order of the coordinates and make the second coordinate negative, or change the sign of the second coordinate. So switch the order, change the sign on the second one. Now if we go counterclockwise, my bad, you're still going to switch the order of them, but instead the first coordinate will now have its sign changed. Now for counterclockwise, it doesn't matter which direction you go in, or no matter which direction you go in, the image will be the same. So you're going to keep X and Y in their same position, but change the sign. So positive X, positive Y will become negative X, negative Y. Now, let's say we're going clockwise 270. That is going to look like this. Okay. Notice you end up in the same position as if you ended up counterclockwise 90 degrees. So your coordinate XY will become negative YX. Yes, these do match. And if we do counterclockwise 270, look at that. It looks like it's going to end up where you would with clockwise 90. And that is true. Switch the coordinates, change the second one to a negative. So those are the rotation rules. Let's go ahead and put them in practice. So triangle PQR has vertices P negative 1, 8, Q 4, negative 2, and R negative 7, negative 4. We want to draw the image of PQR after rotating 90 degrees counterclockwise about the origin. So I've gone ahead and sketched our pre-image. And now remember, 90 degrees counterclockwise. If we start with some coordinate AB, we're going to switch the order and make the first one, change the sign of the first one. So for example, for P, if we switch them, we get 8, -1. And then we're going to change the sign of the first coordinate. So since it's a +8, we're going to turn that to a negative. And then keep the new y coordinate the same. For Q, switch the order, we get -2, 4. Make the first one, change the sign of the first one. So -2 becomes a +2. Keep the sign on the second one. Now for R, switch the order, we get -4, -7. Change the sign of the first coordinate. The image of R is at +4, -7. And now let's sketch it. So P is at -1, 8. Nope, I'm a liar. It's at -8, -1 now. Q is at 2, 4 now. And the image of R is at 4, -7 now. And we've gone ahead and drawn our new triangle. So we've rotated it counterclockwise 90 degrees. Okay. So all these examples so far have been level 2s, where you go ahead and just follow the transformation. Level 1s, like down here, are just going to ask you what transformation took place. So for this one, we are going from A to B. Looks like a reflection. Now you do have to be a little more specific, because you could reflect across any line or point. So I can see this is a reflection across the x-axis. And that's it. Example 5, we're going from A to B again. Well, looks like we turned the image. And since we're starting at A and ending at B, looks like we went counterclockwise. So rotate counterclockwise 90 degrees. Now for level 3s, we are going to be performing a sequence of transformations. So for our sequence of transformations, we're going to take the X, Y, and Z and rotate them 90 degrees counterclockwise first. Then we are going to reflect across the x-axis. So let's start with the rotating 90 degrees counterclockwise. For that one, we take our coordinate, whatever it is, A, B, switch the order and make the first one negative. So for 0, -1, that will become 1, 0. For 3, 1, that will become -1, 3. And then for 1, 5, that will become -5, 1. Now we aren't done yet, because now we have to reflect across the x-axis, which just changes our second coordinate sign. So 1, 0, since it's 0, it's going to stay as 0, because you can't have a -0. -1, 3 will become -1, -3. And also the notation for this will have 2 apostrophes, because we've done 2 transformations. So Z -5, 1 will become -5, -1. And we've done our transformations. Now we plot our points. So 1, 0 goes right here. -1, -3 goes right here. And -5, -1 will go right here. And we are done with that. Let's move on to the next one. So perform the transformation on triangle ABC with vertices A 1 1, B 3 5, and C negative 3 2, which has been translated 4 units down, 2 to the left, and then rotated 180 degrees counterclockwise. So translation 4 units down, 2 to the left. It's kind of backwards here, but 2 to the left is going to be our change in x, so that's x minus 2. And then 4 down is y minus 4. So you're going to subtract 2 from the x and 4 from the y. So 1 minus 2, comma 1 minus 4, which just gives us negative 1, negative 3. B is going to be 3 minus 2, 5 minus 4, which gives us 1, 1. And then C is going to be negative 3 minus 2 and 2 minus 4, which becomes negative 5, negative 2. Okay. And then we're going to rotate 180 degrees counterclockwise, which just flips the sign on all of them. So negative 1, negative 3 becomes positive 1, positive 3. 1, 1 becomes negative 1, negative 1. And negative 5, negative 2 becomes 5, 2. And then you're done. Let's plot our points now. So the image of A is right here at 1, 3. The image of B is at negative 1, negative 1. And the image of C is at 5, 2. And you are done. So those are level 3s. Now level 4, we have to work backwards from what we just did. You're going to be given an image and a pre-image, and you want to see what happened to the pre-image to get our transformation. And part of this is kind of just guessing and seeing what happened, but there's a few things you can look out for. So we're looking for a series of transformations that would map figure E, which is this one right here, onto figure F, which is right here. Well, from what I can see, it does look like we have a reflection across the y-axis. Okay, so let's go ahead and reflect figure E across the y-axis. Okay, and doing that looks good so far. Now, looks like we've slid up. So I'm going to take this bottom point right here and count how many units up we go until we get to this point. So 1, 2, 3, 4, 5, 6. So we go 6 units up. And we are done. We've mapped our images perfectly. And you could always check, make sure everything has moved up 6. But it looks like we are matched up. So, like I said, this one's kind of just guessing and checking to see what transformations will get you your image. And there might be multiple paths, but just guess and check and see where you go. Let's do a couple other examples. For this one, it looks like we have rotated because this is the top here, or that's the side that moves to the top here. So we do have a rotation. And because we're going like this, just moving the side to the top, I'm going to guess 90 degrees counterclockwise. Let me go ahead and plot that for us. I lied, this is 90 degrees clockwise, by the way. There we go, so we've rotated it clockwise. And it looks like now all we gotta do is reflect our image across the y-axis. Okay. Now, this one also would have worked if we did start by rotating 90 degrees counterclockwise. So let's take a look at that. So if we rotate it like this instead, as you can see, all we have to do is flip across the x-axis. So there are multiple paths you can take. Okay, let's do one more. We want to determine a series of transformations that map J onto figure K. So first I can see a rotation, clockwise I mean. -90 degrees. And it looks like this if we rotated 90 degrees clockwise. And then it looks like we're sliding 1, 2, 3 to the right. So translate 3 right units. And we are done now. So go ahead, complete the summary on the following page, and get started on the next assignment. If you have any questions, just let me know. Have a good day. Bye.